Hey guys, it's Malta here, and in today's video we are going to continue learning how to evaluate limits analytically. Specifically, we're going to learn how to use factoring along with rationalizing to simplify a limit to the point that it can be evaluated through direct substitution. So without any further ado, let's get into some examples. So the first example that we had is problem number 41. And in problem 41, we have the limit as x goes to 0 of x squared plus 3x all over x. Now, before we actually solve this problem, one thing that I briefly want to point out is that if you were to try to use direct substitution in this case, you would end up with a result of 0 in your numerator over 0 in your denominator. And unfortunately, that gives you an answer of undefined, because you can never do division by 0. And if you ever have a situation in which you're dividing by 0, you're going to end up with a result that's undefined. And the problem with undefined in this case is we need to find a numerical value. So direct substitution in this instance is just not going to work. So what we're going to do is we're going to use a technique called factoring. So what we're going to end up having is we're going to say the limit as x goes to 0 is x times x plus 3 all over x. Now all that we did in this case was we factored the numerator. So our x value, we had an x variable that was shared throughout our two entities, x squared and 3x, and so we can factor that out to get x times x plus 3. Now this is very beneficial because we have an x in the numerator now and an x that previously existed in the denominator. So what we can do is we can actually cancel these out, and we end up getting the limit as x goes to 0 is just x plus 3. And at this stage we can just do some direct substitution, and we get 0 plus 3 equals 3. So there we go. That's the first problem complete. And this really kind of gives sort of a brief glimpse at what we're going to try and do. We're always going to try and simplify the problem down to the point that we can use direct substitution. Now next up we have 43, and so in 43 we have the limit as x goes to negative 1 of x squared minus 1 all over x plus 1. So we're going to try and use the same sort of factoring technique here again. So we're going to have the limit as x goes to negative 1, and what we're going to do is we're going to factor this numerator. And so x squared minus 1 factors down to x plus 1 times x minus 1 all over x minus 1 as we had initially. And once again, we have a common term in our numerator and denominator, which is the x plus 1. So we can actually cancel these out as so, and we get the limit as x goes to negative 1 is x minus 1. And once again, we can do direct substitution. So we get negative 1 minus 1, which is equal to negative 2. Now, I'm going to scroll the page here a bit because this next problem 45, is a little bit trickier, I would say. So in problem 45, get this up. In problem 45, we're being asked to find the limit of x as x goes to 2 of x cubed minus 8 all over x minus 2. So before we actually get on to factoring this numerator, we have to recognize that this is a difference of cubes. And so if we have a difference of cubes, there's sort of a general, I guess, little formula that we can use in order to factor and simplify them down. So this formula is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Now, the way this formula applies in our case is our a variable is just x, because x cubed will give us, obviously, x cubed. And our b variable is 2, because 2 cubed will give us 8. So in this case, we're looking at x cubed minus 8 equals x minus 2 times x parentheses squared plus x times 2 plus 2 squared. So it's like this. And this simplifies down to x cubed minus 8 equals x minus 2 times x squared plus 2x plus 4. So this is what this x cubed minus 8 difference of cubes simplifies down to. And so now what we're going to do is we can say the limit as x goes to 2 is x minus 2 times x squared plus 2x plus 4 all over x minus 2. And you'll see in this case as well, we can eliminate this x minus 2 as it exists in the numerator here and the denominator over here, and we just end up getting the limit as x goes to 2 is x squared plus 2x plus 4. And now direct substitution can be utilized. So we get 2 squared plus 2 times 2 plus 4, and 2 squared is 4, plus another 4 is 8, plus another 4 is 12. So we end up getting a value of 12. So there we go. That problem is now completed. So 47 here. So next we got 47. And 47 is asking us to find the limit as x goes to 0 of x over x squared minus x. Now, really our only main difference that we are going to encounter is that instead of factoring the numerator as we've been doing for the last 3 previous problems, we're going to factor the denominator. So we're going to get the limit as x goes to 0 is just x over factor out an x, and we get x minus 1. So this is fine and dandy because we have an x in the numerator. We can cancel that out with this x in the denominator. So then we're left with the limit as x goes to 0 is 1 over x minus 1. And if we do some direct substitution, we'll get this as 1 over 0 minus 1, which is going to be 1 over negative 1, which ends up giving us a result of negative 1. So there we go. Now I'm going to scroll the page here again, and we have now this time problem number 49. So in 49 here, what we have is we have the limit as x goes to 4 of x minus 4 all over x squared minus 16. So once again, we're going to have some more factoring to do in this situation. So the limit as x goes to 4. X minus 4 in the numerator is going to remain. There's no way we can factor that or mess with it at all. But x squared minus 16, we can factor a bit. So this becomes x minus 4 times x plus 4, which is great because now we have common terms, the x minus 4 in the numerator, the x minus 4 in the denominator. Once again, we just simply have to cancel those. Those are gone, and we're left with the limit as x goes to 4 is 1 over x plus 4. And then we can now do direct substitution. So we get 1 over 4 plus 4, which is 1 over 8. So there we go. So that's problem number 49 complete. Now I got 51. And 51 is a little bit trickier. We have to use a new factoring technique here, but hopefully it shouldn't be too bad. So we have the limit in this case as x goes to negative 3 of x squared plus x minus 6 all over x squared minus 9. So what we're going to do in this case is we're going to do some factoring, but for the first time we're going to be factoring both our numerator and our denominator. So we're going to have the limit as x goes to negative 3, and x squared plus x minus 6, that simply factors down to x minus 2 times x plus 3, and x squared minus 9 factors down to x plus 3 times x minus 3. So as we've had previously, we have a common term here in our numerator and denominator. We have a shared x plus 3, so we can cancel those buddies out, and we get the limit as x goes to 3, or negative 3 I should say, is x minus 2 over x minus 3. And this is good because now we can utilize direct substitution once again. So we're going to have negative 3 minus 2 all over negative 3 minus 3. And so this simply simplifies down to negative 5 over negative 6, which if we get rid of those negatives just becomes 5/6. So there we go. That problem is complete. 51 is now done. So we'll scroll this down again, or I'll attempt to. Oh, there we go. Alright, so now we have 53. And 53, I must say, is going to be a little bit different. We're not going to be doing any more of this factoring. We're going to be imposing some rationalization. So in 53, we have the limit as x goes to 4 of the square root of x plus 5 minus 3 all over x minus 4. Now, as I did with our very first problem, I'm going to point out that if you try to use direct substitution here, you would end up with having a value of 0 in your denominator, which is no good, because that automatically means we're going to have a result that's undefined, and we don't want that. So in this case, what we're going to do is we're going to, I guess, use some rationalization here, in this case of our numerator, in order to try and simplify this down so that we can find the limit. So we have the limit as x goes to 4, and what we're going to do is we have the square root of x plus 5 minus 3, and all that we're going to do is we're going to multiply this by the square root of x plus 5 plus 3. And then we're going to incorporate our denominators here. So we have x minus 4. We're going to do the same thing as we did to our numerator. So we're going to put this times x plus 5 in the square root plus 3. And so what this is going to end up doing for us is we're going to get the limit as x goes to 4 is x plus 5, as you can see. It's going to be x plus 5 minus 9 all over x minus 4 times the square root of x plus 5 plus 3. Now, I'm not going to simplify the denominator, and you're going to see why I don't want to in a little bit here. Because what we're going to do is we're going to get the limit as x goes to 4 is really x minus 4 all over x minus 4 parentheses times, again in parentheses, square root of x plus 5 plus 3. Now, I didn't simplify this denominator because we have a common term now in our numerator and denominator, and so we're just going to cancel these out like so. And so we're going to end up with a result here of the limit as x goes to 4 is 1 over the square root of x plus 5, and we're going to plus 3. And so now this is at the point in which we can do direct substitution, which we will. So we're going to get 1 over the square root of 4 plus 5, and then we're going to have outside of it plus 3. So we're going to get the square root, 1 over the square root of 9 plus 3, and that's going to just simplify down to 1 over 6, because the square root of 9 is 3, 3 plus 3 is 6, and we're going to end up with a result of 1/6. So there we go. Now we have 55 to conquer, and 55 is more of the same. So 55, so I'm going to scroll this down here. Okay, that's a little too much. There we go. So 55, we have the limit as x goes to 0. X goes to 0 of the square root of x plus 5 minus the square root of 5 all over x. So as you can see, obviously if we tried doing direct substitution, we'd have a divide by 0, which would result in unfortunately undefined, which can't be the case in this instance. So what we're going to have to do is, once again, we're going to impose some rationalizing of the numerator. Now, one thing to note here is it doesn't matter that, instead of having that there's like a square root, in this case we have 2 square roots. That doesn't matter. We're just going to treat it in the exact same manner. So we're going to have the limit as x goes to 0 of the square root of x plus 5 minus the square root of 5 over x. And we're going to multiply this, in this case, by the square root of x plus 5 plus the square root of 5, and then multiply the denominator by the same thing. So there we go. So now it looks like this, and now we can start multiplying this out and then begin our simplification process. So we're going to end up getting here the limit as x goes to 0, which is x plus 5, because square root of 5 or square root of x plus 5 times the square root of x plus 5 just gives us x plus 5. And then we're going to end up with minus 5, because if we multiply our middle terms, they're going to cancel because we have a positive and a negative. And then the square root of 5 times the square root of 5, with 1 being a negative, is just going to give us negative 5 all over x times square root of x plus 5 plus the square root of 5, like so. And then what this is going to end up doing is this is going to simplify up here to the limit as x goes to 0 is just going to be x all over x times the square root of x plus 5 plus root 5. So once again here we have a common term of x in their numerator and denominator, so we're going to cancel those, like so, or like this I should say, so you can actually see it. And we're going to end up with the result of the limit as x goes to 0 is 1 over 1 over the square root of x plus 5 plus root 5, like so. And then what's going to happen is we are now going to be able to do some direct substitution. So we're going to get 1 over the square root of 0 plus 5, and then plus root 5. And so this right here is going to simplify down to 1 over the square root of 5 plus the square root of 5. Now I'm going to go down over here, and this simplifies that 1 over the square root of root 5 plus root 5 is just 1 over 2 root 5. And that is your answer. Now, some teachers I know will require that you have to rationalize this denominator. So if you want to do that, all that we got to do is we got to multiply the numerator by root 5, the denominator by root 5, and we end up with the result of root 5 all over a nice, very nice value of 10. So there we go. So that we've now covered two topics here. We've figured out factoring, and we figured out rationalizing a numerator. So now what we're going to do is we're going to get into our final stages here. We have a couple more problems to do. Not that many are left. Actually, we only have one left, which is nice. So we have problem number 57 they're going to be trying to solve. And in problem 57, we have the limit as x goes to 0 of 1, and this is all in brackets, well, this first part's in brackets, 1 divided by, and then in parentheses, 3 plus x, and then close the paren, put the bracket on, minus, in parentheses, 1 over 3, and then this is all over x. Now, the first thing I want to point out is I would definitely suggest, if you have a problem like this, rewrite this. For sure. You've got to rewrite it. So this becomes the limit as x goes to 0 of 1 over 3 plus x, because we have parentheses here, which means this is all in the denominator, minus 1/3, and this is all over x. Now, this is a complex fraction, unfortunately, which is something that we don't like, and we're going to have to simplify this. So to do so, we are going to simplify our numerator, and so if we are to simplify this, we're going to get, I'll do this, I think, over here. So we have 1 over 3 plus x minus 1 over 3, and so the way I like to do subtraction is not, I guess, the most efficient, because I like to say we have the 3 plus x times the 3 minus the 3 plus x times the 3, oops, close the paren, times the 3 equals 3 plus x times the 3. So if we do this, 3 plus x divided, if we divide this denominator here by this 3 plus x, we're just going to get a result of 3. 3 times 1 is 3, that goes there. If we do the same thing over here, we're going to have the 3 cancel out, so we're just going to get 3 plus x times 1, which is just 3 plus x. So there we go. Our 3's are going to subtract out, and we're just going to be left with negative x. So that's really how this fraction breaks down. We have negative x now over 3 plus x times 3. So now what we're going to end up doing here is we can now replace this, and we're going to get the limit as x goes to 0 is negative x all over 3 plus x times 3 all over x. Now this still ain't perfect because it's still a complex fraction, and we really have a fraction of negative x over 3 plus x times 3 divided by just really a whole x. So the way we're going to fix this is we're actually just going to carry out the division by x. So what that means is we're going to basically get the limit as x goes to 0 of negative x over 3 plus x in parentheses times 3, and all that we're going to do is we're going to multiply this by 1 over x, because we're trying to divide by x, and whenever you're doing fractions and using division, you always do the reciprocal, so we're going to have 1 over x in this case. And this is nice because, as you can see here, we have this common x that's shared numerator and denominator. So we're just going to end up getting, we have the limit as x goes to 0 is going to give us negative 1 all over 3 plus x times 3. And right now this is looking pretty fine, because what we can do is we can actually do some direct substitution and figure this one out. So we get the limit as x goes to 0 is negative 1 all over 3 plus, and put the 0 in, close the parenthesis, times 3. So we're going to get a value of negative 1 all over 9. And so that should hopefully be our answer here. So there we go. That's our answer. That looked very terrible, but value of negative 1/9 is what we get. So hopefully this was helpful. These were just some examples that I found that I thought might be of use. And I guess the main points that we covered today was how we can evaluate limits analytically through factoring, rationalizing a numerator, and then also I guess through a bit of working with complex fractions, which I guess we learned how to handle back in Algebra 2. So yeah, thanks for watching. If you liked the video, leave it a like, and if you want to receive more content, definitely subscribe. So thank you for watching, and I hope to see you in the next video.